In this video, we're going to start talking about trigonometric functions. So there are actually 6 trigonometric functions. We have sine, cosine, tangent, cotangent, secant, and cosecant. But in this first section, we're just going to talk about sine and cosine. So when we talk about sine and cosine, a useful tool that we use to get values for these functions is called the unit circle. So basically the unit circle is just a circle with radius 1. So I have a picture of this below. So we're going to talk about what this looks like. So the circle is graphed on your normal XY coordinate plane, and we have quadrants 1, 2, 3, and 4, just like you've graphed any other graph probably since elementary school. So the 4 main points on this circle are going to be as follows. So this one over here is just going to be 1, 0. This point at the top is going to be 0, 1. This point on the left side is going to be -1, 0. And then this point all the way at the bottom is going to be 0, -1. So as you can see, we have a circle, and the distance from the center out to the circle is 1 at every single point on this circle. That's why we say it has radius 1. So the special thing about this circle is that when we use radius 1, we can say that every x coordinate is actually equal to the cosine of our angle, and this time I'm going to say that my angle is t because that's what it says in the picture. So t is our angle, and any y value on a point is going to just be the sine of our angle t. So that's the important thing to remember with the unit circle. X values correspond to values of cosine, y values correspond to values of sine. So if we want to think of an equation for our unit circle, we have x squared plus y squared is equal to 1. And another way to write this, since we know that x is equal to cosine and y is equal to sine, is we could say cosine squared of t plus sine squared of t is equal to 1. So this second equation we're going to talk about a little bit more in, I believe, the next section. Yeah. So we won't worry about that too much right now, but we'll get to it in the next video. Okay, so when we talk about the unit circle, we usually start talking about quadrant 1 first because we have some special values that we want to memorize. So we have certain angles that give us nice points that will help us to find sine and cosine. So these angles are 0 or 2 pi. So every time you go around the circle, that's going to be 2 pi. So a lot of these angles could have many different names. So 0 and 2 pi are actually the same angle. And this point we already sort of talked about. We're going to have the point 1, 0. So the cosine of 0 is 1, and the sine of 0 is 0. Our next angle is pi over 6, so that's at this green point right here. And the point we're going to have there is the square root of 3 over 2, 1/2. So what this tells us is that the cosine of pi over 6 is the square root of 3 over 2, and the sine of pi over 6 is 1/2. At pi over 4, we have the point square root of 2 over 2, square root of 2 over 2. So once again, this tells us that the cosine of pi over 4 is square root of 2 over 2, and the sine of pi over 4 is also square root of 2 over 2. And our next angle is pi over 3. So this is actually going to be very similar to pi over 6. We're just going to switch the coordinates around. So the cosine of pi over 3 is 1/2, and the sine of pi over 3 is root 3 over 2. And then finally we have the angle pi over 2, and since this is all the way at the top, we're going to have the point 0, 1. So this tells us that the cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So these are our 5 basic points on the unit circle, and we can take this diagram that we've just labeled and we can reflect it to quadrant 2, quadrant 3, and quadrant 4 and get a bunch of other angles and complete our diagram of the unit circle. So for a completed diagram, I've posted a picture on Moodle, so it would be in your interest to go and look at that because the unit circle is something we're going to be using all semester to solve all types of problems. So it's important that you get these values down as quickly as possible. And not to mention, a question like this diagram would be a great test question when it's time for that. Okay, so we also have a definition for special angles. So like if we have an angle whose terminal side is actually on an axis rather than in a quadrant, we call these quadrantal angles. So an example of this is just a special name for angles like 0, pi over 2. When we get to the other quadrants, we'll start to see pi, 3 pi over 2, and 2 pi, and then any rotation of that. So basically it's all of your angles that are on those positive or negative x or y axes. Okay, so those are quadrantal angles. Another concept that is very important is what we call a reference angle. So a reference angle is basically a tiny angle that tells you all the same information as your original angle. So we're going to let theta be an angle in standard position. So remember, that just means that the vertex of your angle is the center of the circle at 0, 0. The reference angle, which we typically call alpha, is the acute angle formed by the terminal side of theta and the x-axis. So this definition can be kind of confusing, but I'm going to draw you a picture to make it make a little more sense. So let's say that these are our x and y axes. And let's say that I have an angle theta, let's say in quadrant 3. So let's say that this is my angle. And so my point is out here. And so theta would be this angle starting at 0 and working all the way back around to this terminal side right here. So maybe we say that theta is equal to 5 pi over 4. So like if this is pi over 2 and this is pi, and let's say in this example we're just counting by pi over 4s. If we end up in this quadrant, this would be 5 pi over 4. Okay, so that's our angle theta. Now, if we wanted to talk about the reference angle, I'm going to switch my colors. So alpha would be this little angle in here. So this would be alpha equal to pi over 4. So notice it's an acute angle, so that means that it's something between 0 degrees and 90 degrees, or 0 and 2 pi, or sorry, pi over 2 if we're talking about radians. And so here our reference angle would just be pi over 4. So that's a basic example of what a reference angle is. So this is important because when we want to find values of sine and cosine for stuff that's not in the first quadrant, typically it's much easier to find the reference angle, but then use the quadrant of the terminal ray to get the sine of the trig function. And by sine I mean SIGN, so like positive or negative, not like the trig function of sine. Okay, so we're going to see how that works in just a little bit. So we're going to talk a little bit about, well, where is sine and cosine positive and negative? So if we think about our 4 quadrants, so we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4, we're going to think about where sine and cosine are positive or negative. And remember that x is equal to cosine of t, or cosine of, maybe we'll call it theta this time, and y is equal to sine of theta. So what we want to think about is, well, where are x and y positive and negative? So in quadrant 1, and I mean, you should have been doing this for a long time, so let's think about what happens to the x-coordinate and the y-coordinate in quadrant 1. Well, any point in quadrant 1, both coordinates are going to be positive. So this tells us that the cosine of theta is positive, as well as the sine. So sine of theta is also positive. Okay, in quadrant 2, every point has the form negative number, comma, positive number. So cosine of theta is negative and sine of theta is positive. In quadrant 3, both coordinates are negative. So we have cosine of theta is negative and sine of theta is negative. And finally in quadrant 4, we have our coordinates are positive, comma, negative, so cosine of theta is positive and sine of theta is negative. So remember, even though we're talking about something new, like trigonometric functions, we're relating it back to something you know, which is just x and y coordinates. Okay? So now we're going to talk about the domain and range of sine and cosine. So if you remember, maybe from a previous class, the domain of a function is all the x values. So these are the things that we can plug into a function, and the range is all the y values. So these are all the things that we get out of the function. Okay, so first we're going to talk about the domain. So first, the domain of sine of x and cosine of x must be all real numbers. So we're going to say negative infinity to infinity, and this is just interval notation, so hopefully you've seen interval notation before. If you need help with that or you haven't seen it before, please talk to me, send me an email, and we'll get through it. Okay, so what this means is that we can take any angle and plug it in for x or theta or whatever we're calling the angle in the problem. So this means we can plug in any angle. So let's think about why this is. So when we did our diagram of the unit circle, we basically said, so maybe let's look at this unit circle that we did over here on the left side. We've got a point everywhere on that circle. Okay, we mentioned 4 specific ones, but everywhere on that circle has a point. So that's saying that we have angles all around that circle, and we can go around that circle as many times as we want. So that's saying we can pick any angle ever and plug it into sine and cosine. We're good there. Now the range is a little bit different. So the range of sine of x and cosine of x is going to be the interval from -1 to +1, and we put brackets around -1 and +1 because it can actually take on those values. So let's talk about why this is. So if we go back and look at our circle over here on the left, we notice that the biggest value that the x values and the y values can take on is +1. So that's like out here at this point and up here at this point. So we've got an x value of 1 and a y value of 1, and that's the biggest it can be. If we move anywhere to the left or right of those angles, those 1s are going to decrease a little bit. And then the smallest value that x or y can take on is here and here. So we have -1s at those coordinates. So what that's telling us is if we go slightly to the left or slightly to the right of those points, we're not going to be at -1 anymore. We're going to be at something slightly bigger. So that means all of our values have to be between -1 and +1. Okay, so just to summarize, the smallest value of sine of x and cosine of x is -1. And similarly, the largest value of sine of x and cosine of x is +1. Okay, and so what I want you to think about, so when you're thinking about the range of sine and cosine, just think about the picture that we just talked about. So I want you to think about those quadrantal angles. Sorry, I always have trouble with that word. So think about those quadrantal angles. So remember, those are those angles. If we think about a small little picture over here, these would be like 0, pi over 2, pi, and 3 pi over 2. And 0 is also known as 2 pi. So it's those angles that are way out on the actual positive and negative x and y axes. Okay, so that's the domain and range of sine and cosine. So now what we're going to do is tie this all together and talk about actually finding a reference angle, but then using that reference angle to evaluate a trig function. Okay, so first we have the sine of 7 pi over 4. So first of all, let's think about where this is on the unit circle. So if 0 is over here, we have pi over 2, which we can think about as 2 pi over 4. Then we have pi, which we can think about as 4 pi over 4. And then we have 3 pi over 2, which we can think about as 6 pi over 4. So 7 pi over 4 would have to fall somewhere between these two angles. So 7 pi over 4 should be somewhere right here. So this is 7 pi over 4 at this dot. Okay, so alpha is going to be the small angle in between that line and the positive, or not necessarily the positive, but the x-axis. So alpha is going to be this distance in here. So how far is that? Well, if we think about this line right here as 2 pi, or 8 pi over 4, and we know that this line here is 7 pi over 4, well, what's the distance between those? So if we take 8 pi over 4 minus 7 pi over 4, that's a distance of just pi over 4. So pi over 4 is our reference angle. So what this is telling us, I'm going to switch back to blue real quick. So this is telling us that the sine of 7 pi over 4 is really just the same as the sine of pi over 4. But maybe this is either positive or negative. We don't quite know yet. Well, since our angle is in quadrant 4, we know that sine is negative, so this is going to take on a negative value. So what we're saying is that the sine of 7 pi over 4 is equal to the negative sine of pi over 4. So let's think about what this is. So our negative sign stays the same, and the sine of pi over 4, which we talked about in our diagram of the first quadrant, is just the square root of 2 over 2. So our value for the sine of 7 pi over 4 is negative square root of 2 over 2. Okay, so notice in the directions we said exact value. Okay, exact value, once again, means that you want to not use a calculator to round your answer. So could we have taken sine of 7 pi over 4 and put it into the calculator? Yes. But if we had done that, we wouldn't have an exact answer. It would have been some rounded decimal. So exact answers are typically fractions, whole numbers, they might contain square roots, they might contain pies, it just depends. But exact value means I do not want you to put it into a calculator. I cannot stress that enough. So let's try another example. So in this next example, we have the cosine of 7 pi over 6. So let's draw again where this is on the unit circle. So this time I'm going to think about my angles in terms of a denominator of 6. So I'm starting with 0. Pi over 2 is the same thing as 3 pi over 6. And then we have 6 pi over 6. And then we have 9 pi over 6. And then 2 pi is the same as 12 pi over 6. So 7 pi over 6 has to fall somewhere just after 6 pi over 6. So that might be right there. Okay, so my reference angle is going to be this little angle in here. So this is alpha. And how large is alpha? Well, alpha is just pi over 6. It's the same idea as the last example. Between 7 pi over 6 and 6 pi over 6, we have just 1 pi over 6. So alpha is pi over 6. So what this is telling us is that the cosine of 7 pi over 6 is really just the cosine of pi over 6, but maybe we have a positive or negative. So that's what we have to decide now. So because we're in quadrant 3, cosine takes on a negative value. So cosine of 7 pi over 6 is actually just negative cosine of pi over 6. And now we can just sub in our value from the first quadrant. So the cosine of pi over 6 was the square root of 3 over 2. So the negative square root of 3 over 2 is the cosine of 7 pi over 6. All right, and let's try one more example with these reference angles. So this time we have the sine of 79 pi over 6. So this one's a little bit more challenging. So maybe once again, let's draw our unit circle in terms of a denominator of 6. So we have 0, 3 pi over 6, 6 pi over 6, 9 pi over 6. So 79 pi over 6, well, 79 is a really big number. And we know that it's not going to be on the first rotation of the unit circle because that only goes up to 12. So we need to figure out what angle has the same position as 79 pi over 6, but is within those small numbered fractions like we prefer to deal with. Okay, so the way that we do this is we need to get 79 pi over 6 down into that first rotation. So what we can do is just start with 79 pi over 6, and maybe I'll do this in red so that it stands out. So if we start with 79 pi over 6, we want to keep subtracting 12 pi over 6 until we get a number that's less than 12 at the top. So if we do this, first 79 minus 12 is going to give us 67. So we'll get 67 pi over 6, but that's still too big. So now we're going to take 67 pi over 6 and subtract another 12 pi over 6. And that's going to be 55 pi over 6. But that's still too big, so we're going to do it again. So we're going to do 55 pi over 6 minus 12 pi over 6, and that's going to give us 43 pi over 6. But that's still too big. So if we keep doing this, we would get numbers like 31 pi over 6, and then if we subtract again, we would get 19 pi over 6, and we're almost there now. And if we subtract again, we'd finally get 7 pi over 6. So this is the same as the angle 79 pi over 6, but now we're within that first rotation. So we said in the previous example that 7 pi over 6 is in the third quadrant, somewhere right here. So this is actually 79 pi over 6, which is equal to 7 pi over 6. So the sine of 79 pi over 6 is just equal to the sine of 7 pi over 6. And so now that we've gotten our fraction down a bit smaller, we can actually think about what this is. So our reference angle now, we can think about the distance between that line and the x-axis. So it's going to be the same as the last example, which is pi over 6. So the sine of 7 pi over 6 is just going to be the sine of pi over 6. But we may have to add a negative sign. And in this case we do, because in the third quadrant sine is negative. So if we think about the sine of pi over 6 from our first quadrant diagram, we would get that our answer is negative 1/2. So the sine of 79 pi over 6 is just negative 1/2. Okay, so that is how you use reference angles to actually evaluate trigonometric functions like sine and cosine. Okay, so in this next example, we're just going to find reference angles and we're going to look at it in terms of degrees. So we're going to take on a little bit different of a perspective. So up to this point we've been doing radians. So this time we want to find the reference angle. We're not going to evaluate anything. We're just going to find a reference angle for 300 degrees. So let's think about where 300 degrees is on our unit circle. So we've been talking about radians. So let's maybe write those first. So we have 0, pi over 2, pi, and 3 pi over 2. But let's talk about what these are in degrees. So pi over 2 is just 90 degrees. Pi is 180 degrees. And 3 pi over 2 is 270 degrees. So 300 degrees must fall somewhere between 360 and 270. So maybe it falls somewhere right there. And it's not really important that you have the line in exactly the right place as long as it's in the right quadrant to give you the idea of whether it's positive or negative. Okay, so 300 degrees falls in quadrant 4. And so our reference angle is going to be between that line and the x-axis. So this will be alpha. So if we think about what's the angle between 300 and 360, well, that would just be 60 degrees. So sometimes these are a little bit easier to think about because we're not dealing with fractions typically. Okay, so let's look at our next example. So this time we have 1,185 degrees. So once again, let's go ahead and draw our 4 quadrants. So this time I'm just going to write them in degrees since we talked about how we got that the last time. So we have 90, 180, 270, and 0 is the same thing as 360. Okay, so the problem with 1185 degrees is sort of like when we did that 79 pi over 6. It doesn't fall in that first rotation, so we need to figure out what is an equivalent angle that's easier to think about. So what we can do is start with 1185 and keep subtracting 360. So we're just going down a rotation every time until we get an angle that has a different name but is in the same position. So if we subtract 360 the first time, we get 825, but that's still too big. So then we take 825, subtract 360 again, and we get 465, but again, that's bigger than 360. So then we're going to take 465 and subtract 360 again, which gives us 105. And 105 is indeed smaller than 360, so we can actually think about where that is. So 105 is going to be a little bit bigger than 90, but less than 180. So maybe we say 105 is somewhere right there in quadrant 2. So our reference angle is going to be between that line and the x-axis. So alpha will be that angle between 105 and 180. So to find alpha, we can simply do 180 minus 105, and that gives us 75 degrees. So alpha is equal to 75 degrees. Okay, and I probably should mention, just a reminder, when you're working in degrees, make sure to draw the degree symbol when you're writing an angle measure. So radians, we don't typically write the unit, but degrees is very important, because if you don't write the degree symbol, then I'm going to assume that you're talking about radians. Okay, so just a reminder there. All right, so we have one more example with reference angles. So let me go back to blue real quick. Okay, so this time we have a negative angle. So we have negative 132 degrees. So all a negative angle means is we're going to start at 0, but we're going to count clockwise instead of counterclockwise like we've been doing. So I'm going to draw my axes again. So if I start at 0 and I start counting backwards, that means we're at negative 90 at the bottom. We're at negative 180 on the left, and we're at negative 270 at the top. Okay, so negative 132 must fall between negative 90 and negative 180. So it's somewhere in between here. So I'm just going to draw it right there. So our reference angle is going to be this angle in here between negative 180 and negative 132. So to find that reference angle alpha, I can just take 180 minus 132, and that gives me 48 degrees. So notice that our reference angle is going to be a positive value. Okay, so reference angles are always going to be positive values. You'll never have a negative reference angle. So even though our angles here were negative 180 and negative 132, I still treated them like they were positive angles and just subtracted them. Okay, so that's important to get through your head. Okay, so we're done with reference angles. So now let's try to tie all of this together into a slightly longer problem. So in this example, we're going to find the cosine of theta if we know that the sine of theta is 3 over 4 and our angle is in quadrant 2. Okay, so first of all, quadrant 2 is over here. So what does that tell us? Well, that tells us that cosine is negative, excuse me. So cosine is negative, maybe I won't write is, that's kind of confusing. So cosine's negative, sine is positive. So our x value is negative, our sine is, or our y value is positive. Okay, well we know that the sine is positive because it was given to us right here. We know that it's 3 over 4. But we still need to find the cosine. So just a reminder, sine is equal to y. Okay, so we can go ahead and find our x value though. So we can use the equation of the unit circle. We can say x squared plus y squared is equal to 1, and we know that y is equal to 3/4 because it was given to us in the problem. So we can say x squared plus 3 over 4 squared is equal to 1. And if I square 3 over 4, I square the top, so I get 9, and I square the bottom, so I get 9 over 16. So now I have x squared plus 9 over 16 is equal to 1. So if I subtract 9 over 16 to the other side, I have x squared is equal to 16 over 16 minus 9 over 16, which is equal to 7 over 16. So now I can take the square root of both sides. So I have x is equal to the square root of 7 over 16, which is equal to the square root of 7 divided by 4. So 16 is a perfect square, so we can go ahead and take the actual square root of that. Okay, so this is the value of x. Now, our job is to decide whether this value should be positive or negative. So up here, because theta was in quadrant 2, we said that our cosine had to be negative. So even though x turns out to be the square root of 7 over 4, we need to say that cosine of theta is equal to negative square root of 7 over 4. That way our sine, S-I-G-N sine, agrees with the quadrant of our angle. Okay, so this would be your final answer. Cosine of theta is equal to negative square root of 7 over 4. Alright, so the last thing we're going to talk about in 5.2 is how to use your calculator. So we've done a lot of this stuff by hand so far. Now we're going to talk about briefly how to use a calculator. So the most important thing is when you're using your calculator, please make sure that you're in the correct mode. So that's what this reminder is about here. So remember, we have two different kinds of angles. You have degrees and you have radians. Your calculator has two different modes, one for degrees, one for radians. If you're not sure how to switch it, so I can't exactly show you how to do it through a video lecture, but if you've never done it before, please talk to me and I will walk you through it on office hours, Teams, or when we meet for class. Okay. It's very important that you know how to do that, because if you're in the incorrect mode, when you do the problem, your answer will be incorrect. Okay, so we need to make sure that you know how to do that. Okay, so we're going to evaluate the following using a calculator, and we're going to round to 3 decimal places. So the most important thing is when you get to a problem that just says use a calculator, again, make sure you're in the right mode. So for part A, we have the cosine of 7 pi over 5. So the way you decide what mode is you look at your angle. It's that simple. So here, our angle is 7 pi over 5, which is in radians. So for part A, we're going to do radian mode. So I'm going to write it off to the side here. So for part A, we need to make sure that the calculator's in radian mode, and all you're going to need to type in is cosine of 7 pi over 5. So as far as the buttons go, that would look like cosine, and then you would type, it'd probably give you a parentheses. Maybe I shouldn't write the buttons. Let's do it this way. So you would type in cosine of 7 pi divided by 5. That's what it should look like. Okay? Depending on your calculator, you may have to type the fraction first and then hit cosine. So get familiar with how your specific calculator works. But most of them you can type cosine first and then the fraction. So anyway, if we were to type this into the calculator, we should get negative 0.309. And so the cosine of 7 pi over 5 should be roughly negative 0.309. And just be careful with the rounding. So WebAssign is extremely picky with rounding, so just make sure that you're rounding things correctly when you're typing your answers in for your homework or a test review. Okay, so hopefully that makes a little bit of sense, but practice punching this into your calculator to make sure that you get the same answer. Okay, so part B, we see that we have 37 degrees as our angle. So that tells us that we need to be in degree mode. So we would need to switch our calculator over to degree mode, and you would simply type in sine of 37, or maybe you have to type in 37 and then hit sine, depending on your calculator. If you do this, you should get 0.6 0.02. So again, practice that on your calculator. Make sure that you get the same answer. If you're having trouble, please see me in office hours or during class, and please ask questions. Okay, so this concludes our 5.2 lesson.